Here's a wild thought. What if making an AI smarter at one thing actually makes it dumber in another? It sounds like a total paradox, right? But for a long time, this has been a known problem in AI development. Basically, the price you pay for progress.
So this brings us to the core question we're diving into today, based on some seriously fascinating new research. When we train an AI to get better at reasoning, to solve complex problems and think things through, are we accidentally making it forgetful?
This isn't just some random worry. In the AI world, they actually have a name for this exact problem.
It's called the alignment tax. And for a while, the conventional wisdom has been that it's a trade-off, plain and simple. When you use these special training methods like reinforcement learning to make a model better at following instructions and reasoning, you've got to pay a price. And that tax, it's a direct hit to the model's ability to just recall raw facts. Its memorization just gets worse.
And hey, this isn't just some obscure theory. As a team of researchers pointed out just this year, there's a growing body of evidence for this trade-off. For a while now, it was just, part of the deal, the accepted cost of making AI more helpful.
But what if that's not the whole story? What if, in certain situations, that conventional wisdom is just wrong? Well, that's where some new research finds a huge crack in this whole theory.
So what these researchers did was pretty clever. They decided to put this whole alignment tax idea to the test using a very specific kind of knowledge, information that's highly organized and structured. Imagine something like the massive, sprawling system of medical codes, where every single piece of information fits into this giant nested tree of knowledge.
Okay, this is where it gets really interesting. The researchers gave a standard AI and a reasoning-focused AI the exact same question about a medical code. The standard one, the one that's supposed to be better at memorizing, tried to just pull the fact from memory and boom, got it wrong. But the reasoning AI, the one that supposedly paid the tax, it actually navigated the complex web of codes, and it found the correct answer. It didn't just remember, it reasoned its way there.
And this wasn't even close. The reasoning-enhanced model blew its counterpart out of the water by a whopping 24 percentage points on this knowledge test. I mean, that's not just a small win. That's a massive performance jump that completely flies in the face of the old theory.
So this creates a really fascinating puzzle, right? If training an AI to reason is supposed to make it forget things, why on earth did it just crush a test that's all about remembering the right information? What is really going on under the hood here?
Well, the researchers came up with this brilliant hypothesis to explain this. And honestly, the analogy they used to explain it is just perfect. Here's the core idea, and it's a real game changer. What if the training isn't changing what the AI knows, but how it gets to that knowledge? It's not about learning more facts. It's about learning an entirely new skill.
Okay, so picture this. Think of an AI's knowledge as this gigantic library, packed with books, all built during its initial training. The old alignment tax theory basically says that when you train the AI to reason, you're yanking books off the shelves. But this new idea, it says, nope, the library is fine. All the books are still there. What that special training actually does is hire and train a super smart librarian, a librarian who knows exactly how to navigate the stacks and find any book you ask for, no matter how hidden it is.
Okay, so that's a great theory, but you've got to prove it, right? So the researchers set up 3 really clever experiments to see if this smarter librarian idea actually holds up.
For the first experiment, they did something so simple, it's genius. They thought, okay, if the standard AI has all the books, but just a terrible librarian, what if we just tell the librarian exactly what to do? So they took that same AI that was failing the medical code test, and they literally gave it a step-by-step cheat sheet on how to search through the knowledge, basically a how-to guide for being a good librarian.
And get this, the results were just incredible. Remember that huge 24-point performance gap? Well, once they gave the AI those better instructions, that gap just collapsed, shrinking all the way down to only 7 points. This is a massive clue. It suggests the knowledge was there the whole time. The AI just didn't know how to find it on its own.
For experiment number 2, they decided to dig even deeper. They weren't just interested in whether the AI got the right answer, they wanted to know if it understood the right way to get there. So they set up a test to see if the AI was following the correct path through the knowledge tree. And guess what? The reasoning AI was the clear winner. Even when both got it right, the reasoning AI was way better at showing its work, proving it actually understood the structure.
Now, this third experiment is my absolute favorite. They basically decided to do an AI brain scan to peek inside the model's heads and see what was actually different between them.
So first, they looked at how the 2 AIs actually store a simple fact, like code 57.95 is a urinary catheter. And what they found was wild. The way they stored that fact, their internal idea of it, was about 90% identical. So the books on the shelf, they look pretty much the same in both libraries.
But, and this is the real kicker, when they looked at how the models processed a question about that fact, like, hey, what is code 5795? That similarity just plummeted to around 70%. The huge difference wasn't in the stored knowledge, it was in the mental process of being asked a question and figuring out how to go find the answer. The librarian's whole approach was different.
So, let's step back. What does all of this actually mean? Well, it could totally change how we think about making AI smarter. It's not just about cramming more and more data into them.
The researchers actually have a great name for this skill. They call it cognitive scaffolding. It's the ability to systematically work through the knowledge that's already baked into the model. Reinforcement learning, in this case, isn't a teacher cramming facts for a test. It's more like a coach who's teaching the AI how to think on its feet.
All right, so let's tie this all together. The big takeaway here is that this alignment tax we've heard so much about, it's not a universal rule. In fact, for complex structured information, making an AI a better reasoner can actually make it better at remembering things. Why? Because it's not about changing what it knows, but improving how it navigates what it knows. It's about changing how an AI thinks.
And that leaves us with a really powerful idea to chew on. For so long, the race in AI has felt like it's about building bigger and bigger models, feeding them more data, just building a bigger library. But what if the next giant leap for AI isn't about knowing more things, but about getting way, way better at using the incredible knowledge it already has?